Thank you for the introduction. Good afternoon, everybody, also from my side. And allow me to jump directly into the topic and start with a general slide already discussed with, I would say, during a few discussions on previous talks. But it is clear that if we talk about green steel, if we talk about reducing the carbon footprint, the biggest burden, the biggest load on carbon dioxide's emissions are given by the iron production and further the treatment to liquid steel. Nevertheless, I also want to include a bit the downstreams facilities into my discussion, as we're finally talking about the final steel product used in automotive industry or somewhere else. And on this slide you can see that also after liquid steel preparation, there is quite a number of carbon dioxide emission connected to the production processes. And also working on this one will improve for sure. And comparing the situation, giving a full circularity on steel production by electric arc furnaces and the use of a high amount of steel scrap for sure improves the situation, as the highest burden is already done within the first life of the steel, and the reduction processes have not to be done anymore. But downstreams you can see also that we can save not by not only changing the process, you have to say, but including processes like the RV, the ESB line, where you can produce thin gauges, maybe allows also to streamline the process, to just skip process steps like cold rolling and annealing, and helping to save some carbon dioxide emissions and energy at the end of the day, also in these steps. And a previous presenter got the question if this already happens today. Here you can see a picture and the layout of a steel mill which was quite recently installed by Primetals in China. And there you can see a combination or a steel melt shop including 2 quantum electric arc furnaces and an ESB line. And the primary target of this line is for sure to produce steel and flat steel directly for the market and streamlining as much as possible on the downstream side and producing green steel. This idea of streamlining downstream processes, I just want to stress for 1 or 2 slides. As I mentioned, the Avedi ESB line, you can see that there is a certain overlap in thickness possible to be produced on these lines, where you normally cannot serve with hot rolling or with other batch-based hot rolling processes. And you have to go to cold rolling. And also, after cold rolling, you have to anneal it to come up with the final mechanical properties asked from the final product. But with the ESB line, you can see that there is a certain overlap, and you can produce hot strip with the minimum thickness 0.8 millimeter, or even already demonstrated during a world record of 0.6 millimeter thin hot rolled strip. And the question is, does this help, or is this already happening? Yes, as I mentioned, the facilities already existing, and nowadays these steel producers are focusing on low carbon material, but also possible products like HSLA grades, advanced high-strength steel grades, or even due to the process, you can even improve the mechanical properties of the final product by applying such techniques like ferritic rolling. So the question raised by my presentation today is, can we produce the same steel as before? Let me extend this question maybe with a second one, more dedicated to the people working in the automotive area who are available today. And my question would be, is it even necessary or is it even required to produce the same steel as before? Or is there also some changes there? If we talk about this direct application idea, it is clear for the functionality of the steel, you have to have the mechanical properties asked for this specific part or this specific piece of steel for this application. But also other factors are playing a very important role, like the surface quality, like the geometrical quality, and for sure the thickness, which was shown, can be reached by certain hot strip mill again. But under certain circumstances, is it possible to even use hot rolled material for final applications? And this will help for sure. And what are the requirements to the automotive industry? I want to shortly discuss on this slide. My colleague already showed a similar version of this slide today, but just let me come from the history. The first cars on this steel development were hand-drawn blueprints where you had, I would say, not that much accuracy on steel forming. And the forming process increased also or developed also in a very big manner that you can really achieve the good quality asked nowadays. And this was done for sure in the 70s and 80s by introducing, for example, the first CAD systems and getting more accuracy in the design and in the formability of the steel. And nowadays it is clear that only CAD construction is not sufficient anymore. There is advanced 3D design and also at the same time simulation where you can get really very accurate results how to design a certain piece of the body construction of such a car, and there is more than one functionality to each part. So also the deforming processes did develop very much, and the accuracy and also the complexity of the steel parts did develop very much. And by such reason, also the content of the tramp elements and the impurities did decrease by increasing formability of the steel. But how can we arrive at this low tramp element content? Today we already discussed quite a lot about copper content in the steel, about other tramp elements, and it was already also discussed and said that a certain copper content cannot be avoided, can be improved, and therefore definitely in future the steel or steel scrap is asked to improve as well as the technologies and the products of steel scrap will increase, the tramp elements will come down. The second one, and which maybe cannot be avoided, is that we have to dilute the liquid steel with virgin material like HBI, like briquetted iron, whatever. But this low tramp element content asked for this drawability and these complex forming processes cannot be reached with the scrap only. For sure, to reduce the carbon dioxide emissions, the highest share of scrap is requested and should be a target to be reached. For the steel products on the deep drawing side, you can see that there is definitely the limit already shown before on the slide, where we can ask of contents of 0.1% of tramp elements. And even with improved scrap qualities, this is not easy to be reached, and there has to be a certain mix of scrap where you can also have a better dilution of the steel scrap by virgin material, and even maybe also circularity of the steel scrap from the production. But not only to talk about bad properties and bad characteristics of the copper, let me also ask or raise the second question, if it's necessary to have the same steel products. As the share of electric vehicles increases very much, also steel grades like advanced high-strength steels are asked. And therefore, for example, copper can also contribute by additional and advanced contribution to also create some steel grades like a drip steel, where the retained austenite is a very important share or a very important topic to get. And as there are not only virtually but also in our room today lots of academic people available, this is definitely something for future development, where also the steel products of today have to be rethought and have to be adjusted to live with this tramp element contents, and even maybe this can be utilized for further new steel products. Second one is for sure that the silicon steel is a very important product for the future, where the share will be increased. And this brings me to the fact that this steel product is definitely one product with the necessity of ultra-low carbon contents. And raising the question of not only the tramp elements, but also the impurities like nitrogen and sulfur, brings us to these properties of the steel, like aging character of the steel. And nowadays everybody is used to have very low nitrogen content, but with the electric arc furnace it is given that we have a bit higher contents of such impurities. And there is a list of measures you can do, and you can apply also to an electric arc furnace, but definitely there is a certain nitrogen level given by an electric arc furnace, and technology showed with our references that this can be even brought down to values of something like 50 ppm and lower. But in general, the used BOFs are showing a very low impurity content like nitrogen. And this is compared on this, I would say, very busy slide, but just let me summarize in a few words that the steel preparation using a BOF route did focus on decarbonization in the secondary metallurgy and the steel treatment. Nowadays, for this electric arc furnace routes, definitely you cannot focus only on decarbonization. You have to treat also for desulfurization and also the denitrogenization. And fact is that the secondary metallurgy will have or will play a much more higher and more importance to generate a high quality final product. And if I sum up a certain study made to produce a ultra low carbon steel grade, you can see that with these processes, the processing time in the secondary metallurgy will come up to values even higher than 2 hours. So all this importance to the steel production will shift also into secondary metallurgy. And how can we tackle that? For sure, it is important to have the right equipment and processes installed, but definitely this is not only a question to having the right processes available. Very important is also to operate them in the right way. And therefore, all this development we are doing permanently together with our academic partners is implemented in our level 2 systems, and the automation will help to guide you through this production process. So allow me to sum up that for these steel products of the future, it is for sure also important to control the tramp elements like before, to have a good crude steel quality, but definitely also the new requirements to the steel products and also some new steel products to be developed will be a very important part of the entire question and answer to arrive at the steel product for an automotive product in the future. At that point, as I think I'm already quite late, and I hope I did not consume too much time, but I'm ready for some questions for that, I'm sure.
Thanks a lot, Bernd, for so many interesting insights about the key success factors to operate an EAF optimally. We have received some questions. Maybe you just choose one of them you would like to answer.
I think the last one I just already answered quite during the discussion. Maybe I also answer what is the green steel definition. Green steel definition, I think, and this is what I wanted to raise, is a question not only by the production, for sure, carbon dioxide emissions are very important, but in future it is maybe possible to really have additional ideas like this direct application idea to bring new products into the final application, where we can even maybe have some new products not accepted today, but maybe in future just to show, to bring a total carbon footprint of the entire process route and production route until the final product to the lowest level. And this is maybe some important additional hint for the future that this can be realized.
Okay, thank you again, Bernd.